Right, hey brother. This one we'll go through the common collector circuit, and we're going to do Monte Carlo and the worst case analysis. Well, let's take a look at the theory behind the Monte Carlo analysis and also the worst case analysis. As I did before, that um, what we have is that when you look for V out, when you do the design, you put the value of all components. For example, you have R1 equal to 50 ohms, and then the R4 is 240K, and that's mean you have no current, or the error is going to be what, zero, plus and minus 0%, actually 0%. But later on, we will put some components to have a current, or we have an error. For example, R is going to be some R, going to be a plus or minus 10%. And we will take a look, uh, what is your V out, or, how much is your V out different than the one that you were put your component with zero percent error. And so let's get started with the first one that we have about six, actually seven working steps that we will go through the one with the Monte Carlo analysis first. We start with the DC operating point analysis, and that's mean we're looking for the base current, collector current, emitter current, and collector, sorry, the base voltage, collector voltage, emitter voltage, and collector current. And this one, we treat this one as reference to see what is the actual output. I mean, this one is in the term of a V out. So let's go through the circuit. What I have here that I labeled VB, VC, VE. So easy to follow when you do a simulation. You want to record all of them. Well, just to refresh for the voltage source, you simply go to component icon here, and then you pick up voltage. You click OK, and then left click to place, right click to cancel, and then you right click uh, on the component, and then for this value, you simply uh, put in 15 volt, and for sinusoidal, you go to advanced, and you can pick up like time. And in this case, I'm going to put the amplitude to be 1 volt. You click OK. So you already have your sinusoidal input source. And you can use scissor here to remove that source. Okay, and actually, when you finish drawing the circuit, you don't have that OP or DC operating point. Well, let's take a look when you go to your simulate. And if you run, you can see this one have so many analysis types. The first one is constant. That's in the term of time domain. Your axis going to be your time. For AC analysis, this one is the frequency frequency domain, and that uh, for the axis, that's going to be the frequency. What is the speed? You want to sweep your input voltage as applied voltage, and that's for the C in the axis. For example, you want to start from 0 to 20 volts. You can limit just put starting value, start value, increment, sweep. You have an object, you have picture, and you know all about it. Okay, sorry. And what else? This one we're going to use the DC operating point. So I click this one, I click OK, and this gives you information about the base voltage, uh, collector voltage, emitter voltage, and also that's what we're looking for, the collector current. Okay, so this one is the first step that we are looking for. The second one uh, asks you to put 4 with plus and minus 10% error, or I think plus and minus percent current. What do you need is that you need to put um, you go to actually you go to main menu, edit, and you go to display diode key, and you can type that uh, as what you want to analyze. Let's get to the second circuit. Here we go. Wherever for MC stands for Monte Carlo. That's we want to do Monte Carlo analysis. And 0.1, that's mean you want to put the confidence to have plus and minus 10% error. And you also want to put dot step parameter. That's parameter 1, 1, 10, 1. That's you want to start from 1, finish 10. Or you want to work on Monte Carlo analysis for 10 runs. And the last one, uh, that's mean the increment. So we are looking for the base voltage, collector voltage, emitter voltage, and the collector current, what and runs. Okay, so let's do it. I already have everything, in the circuit, and I have R4 with the error 0.1, 10%, plus and minus 10%. So let's go ahead and do the run. Um, let's do it again because I did that before. So you go to have the plot, and what you need to do, you go to the plot icon, or at first. And what are you looking for? If you're looking for V out, click OK, right? Or if you want to look for VC, you go to your switches, and this is my. Let's start with VB. That's missing 4. So for the x-axis, the number represent the number of run of Monte Carlo analysis, 1, uh, and you finish to 10. For the vertical axis, that's the your VB in the unit of volt, as you can see. And if you're looking for, let's say, for the run number 3, you simply go to on the top of the window, and then you click on that VB. You're going to have a cursor pop up, and you can put cursor on the vertical line, and you move to the left until you located the number of run to be 3. Okay, you see this one? This is the coordinate XY. Horizontal, that's mean the number of run, and the vertical, that's mean represents the base voltage. You can use the left or right arrow to move around to get like more accuracy for your reading. So you can see that you have here is the 3, and for the vertical, you have the base voltage to be 1.7 or 1 volt. Okay, so this is the working step number 2. Number 3 is working the same thing, except um, you put all resistor. We have the error of plus and minus 10%, but R1, or R1 is like no error or 0% error. And we do the same thing. Okay, so we will continue with the frequency response, in the second part. Um, this one is going to take time. If you want to take a look at the we have VB, great. Let's go to the circuit. Um, this one doesn't work. Okay. Anyway, you're looking for VB, and you're looking for VC. That's why VC actually is V out, and your VE, and you also look for collector current. This one is your collector, right? So you need to repeat your plot with VB. Oops, sorry, let's do this guy, and then you go to address icon. You go to VE, and then you have another plot. And you this guy again, and then VC actually becomes V out. This is your VC. And also the last one, you look for collector current, right? So where's your collector current? Let's get back to the circuit. This one, the collector current. So that's the current that's flowing through R2. Let's get to the plot, and then you look for IR2. Click OK. All right. I'll see you in next series.